and I'm going to start sharing the screen here. So we will talk about your 2.2 first, and then we'll move on to 2.3, and then if you have more questions, and then we'll do a one test 2.4. That's what we're going to talk about today. So 2.2 we're going to talk about is question 24. This is a question says that you have to write area of a square as a function of its perimeter P. So I just want to point out to you that this P is a capital P. So a lot of students ask me a lot of questions during your online homework. They are very picky. So if you put a lowercase p, they will mark you wrong. So make sure you guys know this is the uppercase P here. So so this is talking about square. So a square, the area is the sides times side, which is s squared, and the perimeter is 4s because you add 4 sides and the sides are all the same. So so in this case, we have to find area in terms of P. So what do we do here is we got these two formulas. One is the area formula and one's the perimeter formula. We try to use substitution here. So we plug it back the S to the A. So what we do here is we will solve for S in this case. So so P perimeter in this case is 4S. So in order for us to solve to get S by itself, I will divide this by 4. Okay, so I divide both sides by 4. So in this case, that S P over 4 of the perimeter divided by 4 is the side S in this case. So what we're gonna do next here in this case is we're gonna use substitution. Okay, so we're gonna use substitution in this case. So we plug this into your area formula. So the area formula in this case is given us by S to the power of 2, which is the same thing as P over 4 to the power of 2. Okay, so it will be P over 4 to the power of 2. So you have to square it. Okay, so so what I did here is I take the perimeter formula, solve for S, and then after that I use substitution to substitute it to the S. I'm sorry. So this will be plug it over here, and then you just multiply P over 4 times P over 4. This will give us P squared over by 16. Because P times P is P squared, and then 4 times 4 is 16. So what we have here is, in order for us to do this, you have to do P squared. Make sure the P is a capital letter. Yep, over by 16. So this is how we do this question 24. This is 2.2 on question 24. Okay. Next, we will talk about is 2.3. So 2.3, so this is 2.2. Where's my 2.3 yet? I am going to. So 2.3, we will start at question 16. Okay. So 2.3, we will start at question 16. So this question wants us to graph. So which one is the correct graph out of this? And then finding the interval for f of x equals to greater or equals to 0. If it's empty, enter empty for empty set right in the interval notation. So how do you know which graph is this? Is first you have to find your x-intercept. So how do you figure out your x-intercept? Is you set this whole equation equals to 0. So this is question 16. So to find the x-intercept, you have to set this equation equal to 0. And in order for us to solve this, you have to factor it. So for this case, the common factor here is x. So you can factor the x out and you will get x minus 2 equals to 0. So if you solve for x, x in this case is 0 and x in this case is 2. So you will have, so it will intercept on the x-axis at 0 and 2. And then for the y-intercept, you just need to substitute all your x to become 0. So you get 0 squared minus 2 times 0. So 0 squared is 0, 2 times 0 is 0, so everything is 0. So this telling us that your x-intercept is going to be at 0, 0. Don't forget, you need, this is coordinates, and 2, 0, because that's the 0, 2. And your y-intercept is at 0, 0. So you need to find a graph that fulfill this function here. So you find out that this is 0, this is 0, 0, and 0, 2. So it looks like the answer is this one. Why is not this one is because your x-intercept is not at 0, 2. Same thing here, it's not at 0, 2. This one is not at 0, 2. So the only one that we have here is this graph. So this is how you figure out your graph for this function. And then later on, they want you to find an interval that is greater than or equal to 0. So in order for us to find the interval f of x that is greater than or equal to 0 is very easy. You look at your graph. If you look at your graph, this means that it is the graph will give us the portion that is above the x-axis. Okay, so when you look at this is a graph for him. Okay, this is a graph for this parabola. So if you want to find the f(x) greater than or equal to 0, means you want to take just the one that is above the x-axis. So above the x-axis is this that I'm kind of shading, and then this. So in this case, you will have two interval, because one is going here. This is the positive, and this is the other one because that's above your x-axis. So if you want to go from here, since this graph goes to infinity, so the interval will be from negative infinity to 0. Now, you have to use a bracket for 0 in this case. The reason why you use a bracket for 0 is because your equation has a greater than or equals to sign. The person who used a Galaxy S8, can you change your name to your name? Because I don't know who is this Galaxy S8 is. So someone just got in Galaxy S8. Please change your name. So the reason why that you have to use a bracket here is because of you have an equal sign. So if the question is asking for greater than or equal to, you have to use a bracket on this. If the question is asking for just greater sign, then you just use parentheses. So this is just for that case. And then the other case is from 2 to infinity. Again, we have to use a bracket here because of the equal to. And then you have to put a union symbol in this case, a U. So this U is telling us that it is, you have 2. So if you have a multiple domain in this case, for this case, you will have to keep on putting U. But this since we only got 2 lines that is above this x-axis, so you only have 1 U. Now, so when you type this in your answer, so the infinity symbol should be under symbol here. So it's negative infinity, which is right on this under symbol, that's infinity. And then it goes to 0. And then you bracket it. Okay. I don't know why this one's so weird. Okay, let me go up and bracket. So this is, and then the union, the U symbol, you do not use the capital U. If you use the capital U that I just put it out here, this is not the union symbol. So in this case, you have to go under relation. Let me see, I think it's fun. Let me see, where was that at? It's somewhere over here. Set. Okay, you have to go under set, and then you go this U. That's the union. Okay, so this is the union that you have to pick, not you have to use, not the capital U, and then bracket 2 to infinity. Yes, typing this takes longer time. And then you close your parentheses. So this is how you, this is your answer in this case for question question 16, doing the intervals for which is increased greater than or equals to 0 in this case. Okay, so you go from negative infinity to 0, which is the first part, and then after that 2 to infinity for this case, right? So this is question 16. We're gonna go on to number 22 first before we go to 23. Now this is a one that's sketching graph, so I want everyone here to pay attention because this is where yeah, I'm doing 23. Yes. The reason why is a lot of students asking me, how do I do graph on this? Your graph is correct, it's just that you do it wrongly. So please pay attention here. This is very important. First thing first is a graph is 2 lines. So when you click on this, you got 3 options. There are 3 different options, not the same one. This one is 2, this is called line segments. This is array and this is a line. So you have to use a line in this case. So you have to click on this one, 2 arrows. If you do one of this or the other one, you will get it wrong. So make sure you use these 2 arrows. Now this equation is f of x equals to -5. As you guys know that f of x equals to -5 is the same thing as y equals to -5. And for y equals to -5, this is a horizontal line that cross over at -5. So how do we do this? Is it will be just this line. This is the line that you have to draw. So what you do is you just need to click 2 points for this line that cross at y equals to -5. So you can click one here, and then you can click somewhere here, and they will automatically draw you a line, and that's it. That's what you need to do here, class. You do not need to click. You just, again, let me repeat how do we do it. I'm going to click again one more time so you guys can see what we're doing. First, choose the line. This is the line. This is the array. This is a line segment. This is a line. And then plot 2 points on the graph. So this is -5. So I plot 1 point here and I plot 2 points here. So once you plot the second point, the graph automatically draw for you. So you do not need to do anything. And that's how you do the graph. So make sure you guys know how to draw it. It's not that difficult. It's just you need 2 points. And make sure you don't pick anything else. Don't put the point here. Pick the line segment here. So this is how you do this question number 22 here. Okay. So we're gonna do 23. You have to put 2 points because in order for you to draw a line, you need 2 points, Gianfranco. So you need to put 2 points. So same thing probably on number 6. You have to, in order for you to draw a line, you have to do 2 points. Every time when you draw a line, you need 2 points, at least 2 points to draw a line. Okay. So I am going to do 23. Gianfranco, what's mean by on number 6? Can you explain what is the meaning of number 6 here? Okay. So question 23. So this is the A to E. So we're going to talk about this. This is very important. And a lot of students get this one and doesn't know how to do. So please pay attention here, class. I also saw that you guys did not go back and watch the videos. It's already posted in YouTube. If you doesn't know how to do a question, which is already did in this Zoom session, please go and watch it, because don't ask me the questions. I will say, well, go watch the Zoom video because you already go through this already. So this question wants us to find the domain and range for this function f. So the domain is all the x value. So the x, because this one doesn't have an arrow, so it means it starts at -4 and it ends at, I think it's 5 because 4. So it ends at 5. So your domain in this case will be from -4 to 5. But -4, you see an open circle, a closed circle, so you have to use a bracket in this case. Okay, so -4 is a bracket, and then comma. Where's my friend comma? Here you go. And then 5. But 5, if you look at the 5, this is a open circle, so you have to use a parenthesis in this case. So this is the domain for this function of f. Range is a y value because this one goes all the way till 0. So it will start from 0 and it goes all the way till 9. Now, since they touch us at 0 and they touch us at 9, so you will use bracket in this case. So this is what your range for this function f. Next, you have to find the 0 of f. So if a question gives you like this, means they want you to do as a coordinates point. This is coordinates. 0 means x-intercept. So if a question is asking you to find the 0, it means the x-intercept. So the only point that is crosses on the x-intercept is here. This is the point that is crosses the x-intercept. We call it as your 0. So that's why the 0 for this case is 3, 0. Okay. So the 0 for this is 3, 0 because the coordinates for this point is 3, 0. Again, 0 means x-intercept. Next, increasing, decreasing, constant. So if you read this graph left to right, this graph is going up. So it's an increasing. And then this is going down, decrease, and this is increase. I just want to point out to you that all the increasing, decreasing constant function, you have to use parentheses. Since there is no constant function, so we do D and E. So increasing, we got 2 from here to here, and then from there to here. So there are 2, so we have to use a union sign. So it is from -4 to 0. Don't forget, it's on your x, not on your y. So it's always your domain. So it goes from -4 to 0. This is the first part of it that is increasing. And also they increase from 3 to 5. So you have to use the union symbol that under relation, that's under set, that's a union. And then you go from 3 to 5. And they all are in parentheses. I don't care if they have open or close or touch or no touch. They're all using parentheses here. Decreasing, it goes from 0 to 3 because from here to here it goes down. So it's 0 to 3. So again, all parentheses. So this is how we figure out the increasing, decreasing, and constant. Next, relative maximum and minimum. Again, they give you x, y, means this is in coordinates form. So they want it in coordinates. So relative minimum means the lowest turning point. This is the lowest turning point, and the coordinates for this lowest turning point is 3, 0. So this is 3, 0. Okay. Class, this is already given parentheses, so you do not need to give an extra parenthesis here. Relative maximum means it's a turning point on the max. So this is a turning point on the max, and the coordinates for this turning point is 0, 9. Okay, and then lastly is this even, odd, or neither? So how do we figure out if it's even? Even function is where it is symmetrical with respect to the y-axis. That means that it's like a parabola. So if you draw yourself a parabola, it is even because if you have a parabola, it is symmetrical right on the y-axis. Odd means it's symmetrical at the origin. For this case, it's neither because it's not symmetrical on both y-axis and on the origin. So this is considered neither in this case. So this is how we do question number 23 in your 2.3 homework. Okay, so this is how you do the question 23 in 2.3 homework. Someone asked some questions here. I missed the last Zoom. Yes, Mohammed, you missed the whole week of class. Yes, they all is in D2L, and you got 4 homework due tonight. Yep, you have to. It's gonna be there. Yep. So all the Zoom meetings is posted on D2L. Please go and watch it. Okay. So this is how we do your homework on 2.2 and 2.3. So we will continue on 2.4 today. That's our class, and then 2.5. So I still have the S8. Who was that? Does anyone? Can you change who was the S8 person? Samsung S8, whatever the name is. You have to change your name because when I take attendance later on, I do not know who you are. Okay, next we'll talk about is 2.4. So 2.4, mostly on 2.4 is a library of parent function. This is where they will teach you all the functions that is important. So like this case, we have a fx equals to ax plus b. This is like y equals to mx plus b. So you have a straight line here. Okay, this is a parent function. Your domain and range in this case is all real numbers. So if I give you a straight linear line, your domain and range is always all real numbers. If you have a slope that is not equals to 0, your slope is not 0, then the range is a set of all real numbers. In this case, the range is all the same. Your x-intercept is -b over m0, and your y-intercept is 0b. And then we call this is increasing because your slope is positive. And then when you go down, your slope is decreasing. And then when your slope is 0, means it's flat horizontal. Okay, so mostly this is basic linear functions. Next, we will talk more is a squaring function. A squaring function is a parabola. Notice some important point on this parabola. We always have a 0, 0, and then have 1, 0, 2, 4. You just substitute variable numbers here. Like I put 1, I get 1. I put 2, I get 4. That's why I put -1, I get 1. I put -2, I get 4. So this is how your squaring function of parabola. And this is just x squared. So we doesn't do anything with x squared plus 4 or anything yet. So you need to know this basic function before we move on to 2.5, because all these basic functions will come in handy. Your domain for squaring is all real numbers. Your range is non-negative, means it starts from 0 and it goes all the way to infinity. It intercept at the origin 0, 0. This intersection point 0, 0 is very important. It's because in next section 2.5, we will going over transformation. And transformation is where you start to move things around. Okay. It decreased on the left side from -infinity to 0, and it increased from 0 to infinity. And this is what we call as symmetry with the y-axis, because if you draw on a y-axis here, they are kind of reflections. Okay, so if this is symmetry with the respect with the y-axis, then we call this as your even function. Okay, so if you want to figure out even odd, symmetrical, and it has a relative minimum at 0, 0, so it means it has a turning point at 0, 0. Okay, so this is a squaring function. Cube function, x cube. X cube function looks something like this. This is a cube function where you put 0, you get 0. When you put 1, 1 cube is 1. When you put 2, 2 cube is 8. So when you go 2 is 8. When you put -1, you get -1. When you put -2, it goes down to -8. So this is a cubic function. The domain and range for this cubic function is all real numbers. So everything from negative to positive infinity, because this eventually will go to negative and positive infinity. It is an odd function. An odd function means that it is symmetrical with respect to the origin. So what does it mean by symmetrical with respect to the origin is if you take this piece, this whole function, if you flip it on the x and the y axis, you get back the same thing. So when you take this, if you flip it on the y axis, it becomes like this. And then when you flip it back to the x axis, you get back the same graph. So that means that this is the meaning of symmetrical with the origin. It has an intercept at 0, 0. And then it's always increasing. This graph is always increasing, never decrease. So if you keep on going up. Okay, so this is a cubic function, power 3. Square root function looks something like this. This is a square root function. Domain for this is 0 to infinity, including 0. Range is also 0 to infinity, including 0. That means that your square root function can only be in quadrant 1. But once you have +3 or minus, like if you take a -3 here or +5, then your graph will be different. Okay, but this is just a basic square root of x. It has a 0, 0 origin. And then the graph is always increasing from 0 to infinity. So I want to point out how I got this point is I just plug it in. So I plug 1 in here, square of 1 is 1. I plug 4 in here, square of 4 is 2. And then the next one I do is 9. So root of 9 is 3. So this is how you do your square root graph in this case. Okay. Now, which is not including in this is a cube root graph. A cube root graph will look something like this, which is kind of like 90 degrees rotate of your cubic graph. So if you take this cubic graph and change it sideways on, you will get a cube root graph. This is a cube root graph. Your domain and range is always all real numbers for cube root graph. And it always have a 0, 0. It's an odd function and it's always increase from negative to positive infinity. Reciprocal graph is 1 over x. 1 over x, you will get yourself something like this is your graph. This graph will never cross your x and your y axis. We call it as your asymptotes. So your domain and range for this graph is from 0 to infinity, infinity to 0. It's an odd function. It does not have any intercept, so it won't cross on your x and y axis. It is decreasing from negative infinity to 0, and then from 0 to infinity. So this graph is keep on decreasing, okay, and it is symmetrical with the origin. It's odd and origin. So this is the reciprocal functions. You will learn these reciprocal functions in chapter 4. Yes, chapter 4. Next one is a step function. So it looks like a staircase. We call it as the greatest integer less than or equal to x. So this is a double brackets here. And so what happened is if you have a 3, the greatest integer will be 3. If you have 3.2, the greatest integer is 3. If you have 3.9, it's still 3. So it's not rounding. Some people think this is round, or 3.9 should be 4. No, it's still 3. So what happened is that at 3 to 4, any number that falls between 3 to 3.99999, you will still get back 3. But once you hit 4, you have to, your answer will be 4. So this is kind of like a step function in this case. The domain is all real numbers, but your range are integers. Integers like -1, -2, 1, 2, 3, 0. So these are what we call as integer. It has a y-intercept at the origin 0, 0, and an x-intercept from 0 to 1. Okay, and it's constant every time. So that means it lay flat. It's like a staircase. So what happened is once it's over, you jump on to the next vertically. So kind of like a staircase in this case. We call it a step functions. Okay, so we'll talk more about this step function so you guys are aware about it. Okay. So let's talk about the step function here. So this is the greatest integer of x plus 3. So what happens if the question wants to find f of -2? So you plug -2 here, and -2 plus 3 is 1. So that will give us 1. So f of -2 is 1. F of half, so you put half over here, and half plus 3 is 3.5. So what is the greatest integer for 3.5? It's not 4. So don't put 4 here. You will get wrong. Okay, so your answer should be 3. 4.2, you plug 4.2, so 4.2 plus 3 is 7.2, so the greatest integer in this case is 7. So I just want to point out to you here is this is not the same as rounding. I know you guys know how to round, right? Oh, 5, round up. Not the same as rounding. Now the negative one is very tricky. So when you put -2.16 on here, and when you add 3, it's -18.6. A lot of students think that this greatest integer is -19 because 18 and you go 19, right? Your answer is wrong. It's not -19 here. It's still -18 because this number is actually bigger than -8.6. So we want something that is bigger than no, -18. Now smaller. I want something smaller than the -18.6. So that's something smaller than him. So -18 will be the correct one. So please, I want to point out to you guys that don't round up when you see a negative at all. So just for my rule of thumb to you is just ignore this number here in this case. Okay, just ignore this number, and that's how you find the greatest integer. And how you graph this, this plus 3, if you know transformation, means we move left 3. So left 3 means it used to be on 0, 1. So you move left 3, which is right here. So it looks exactly like this graph, but you move everything to the left 3. So when you move all these stairs to the left 3, this is what you will get. Okay. We'll do one example on your homework so you guys can see what is going on here. So if you look at your homework 2.4, where's my 2.4 homework? This question wants you to do a greatest, like number 13, the greatest integer for x minus 4. So in this case, they only want you to graph from 0 to 4. So what is the best way to do this question 13 here is substitute. So you put, since you want to start at 0, so you start plotting x becomes 0. So when you put x becomes 0, it becomes -4. So you will get a -4. So you start at -4. Now, as you know that if you look at the picture that I drawn here, this graph is kind of like open, close, open, close, open, close. So it's not an arrow, it's not a line, it's not a ray, but it is a line segment. So you have to pick this option to go. So it starts from, so that is from -4. So you have to go -4, and then you go to 0. Okay, and you need to, one is, if you look at the graph that I have here, it starts with a close and then it ends at open. So in this case, it has the same thing. So it starts at close and then it ends at open. So you have to right click this and select open. Okay, open, there you go. So it has to be one close and one open like this. And you have to keep on drawing it. So you have to, so this is the first one. And then next, you go up like a staircase. So from here to here. And then this has to be, so you click on line segment 2 and you click it open. So make sure that one is closed, one is open, and you have to keep on doing this. So you have to do it a few more times. 1, 2, do like that. And you cannot go over, so you only go for one interval like this. And then go to line segment 3 and make it open. Sometimes I click on it, they will automatically change it for you. So 1 and 3, and then click on that circle, and then they will make it open. So this is your answer for this case. So it's kind of like a staircase. And how do I know it's -4? I plug 0 inside here. 0 minus 4 is -4. So I start from -4 and then I slowly goes up. So this is how we do this kind of graph in your homework. You guys doing all right here so far? Okay. Next, we're going to talk about is how do we graph a piecewise function. Okay, so this is what we call as piecewise function. So in order for us to graph a piecewise function, you draw two graphs. So the first graph we have is y equals to x plus 2. I just changed my g of x to become y. But x in this case has to be less than or equals to -5. So what do we do here in this case is you just graph y equals to x plus 2, but it's array. So you're going to use array here. The reason why we use array here is because it is not the whole line. You just get partial of the line. And how do we graph this is you plug in -5 first. So because it starts from -5. So we plug in -5 into the equation. So y in this case is -3. So -5 take a plus 2 is -3. So -5, -3 is here. This is where it starts. So you click on it. And then you put another point you want, but make another point. Again, when you graph, you need 2 points. So you have to use any x number that is less than -5. So you cannot put 4, you cannot put 2, you cannot put 3. You have to put any number less than -5. I'm going to use -6. So I plug it into the equation. So -6 plus 2, which is a -4. So you will put another point, -6 and -4, and this is how you draw your graph. And you will have, so this is, and this arrow goes down like this. So this is how you draw the first one, okay? Next one is the same thing, but now you plug in for x is greater than -5. So you still need to plug in, so the first value we use here is -5. But then a lot of students ask you, well, David, if you look at this question carefully, it doesn't have an equal sign. Yes, it doesn't have equal sign, but it is still, you can still use something that is close to -5, like -4.9999. So in this case, when you use this circle has to be an open circle. Okay, this circle has to be an open circle. You have to use a -5 to use. So plug in -5 into this equation. You will get -0.5 times -5 minus 7. Okay, so 0.5 times -5 is -2.5. So this is -9.5. So you have to put -5, you will be at -9.5. So you have to select the array again, and then you go to -5, -9.5, somewhere here. Okay, if you look at this, it's not 9.5, right? So we'll change that. I'll teach you how to change this so that it become 9.5 because it has to be 9.5 in this case. And then now we will pick another point. So we don't pick -5. Let's put 0 because 0 is greater than -5 and 0 is easy because of the stupid fractions you see there. So 0.5 times 0, which is 0. That's why I use 0. -7. So you get -7 here. So at 0, you get -7. So you just click a point here. So this is the point, but unfortunately, this 9 has to go to 9.5. So you go to ray 2, and then you have to change this 9 to 9.5. Okay, and also you also have to change it to be an open circle. And the reason why you have to change the open circle is because this x greater than 5 is not including 5, -5. So that's why it has an open circle. So this is how we do this question for this case. Okay, so make sure that this 2 is 2 closed circle because of the equal sign, and then the other one is going this way with the open circle. And I know you cannot do 9.5, but you can do this over here. You can put whatever decimals you want, and this is how you do this kind of questions. Okay. You guys are right with 2.4 here. This is how we do question 2.4. Okay, I know some of you will ask me these kind of questions when you guys do your homework. Okay. Next, we will do 2.5, transformation. So this is very important, and yes, we will be doing transformation in chapter 3, chapter 4, chapter 5. How do you change the open dot? Very easy, Derek. You just need to click on the ray, and this is a close, and this is open. You see that? So when you close, you see this is closed right here, and then you click on this, it is open. Okay, same thing here. This is closed, and this is open. But make sure that one of them has to be closed, one of them is open. All right? So you just click on here next to the layer of the graph here. Okay, good. No, we don't use dash and no more dash line, no more. It's always either closed. So we don't use any dash line or in this case, in this class, it's open and closed. Okay, so mostly it's open and closed here, so don't use any dash line. Okay, yep. It's not be dash. I don't see dash. Make sure you put in this option, not the first option. So when you click on this. Yeah, when you click on this, then you will have the dash option. But I recommend if this is the line segment that we're using. Okay, not the ray. We are using, sorry, this question we are using the ray, which is this fellow, not the first one, not the third one. Okay, so make sure you use the correct line in this case. All right, so when we talk about transformation, this is very important. We use this in chapter 3, 4, 5, as I mentioned. So do not forget this. You need to know this. So one is vertical. We call it as vertical and horizontal shift. So it means you go up and down. So how do we know a functions go up and down? Is you have an add or subtract. So for example, like this, you take the square of x and then you add 2 or you subtract 2. So what happens in this case is you take this square of x, this is a square of x graph, and you move it up 2. So your square of x graph will look something like this if you move up 2. Move down 2 means you move it down 2. So that's the reason why that you always have an origin point. This origin point is where you start to move them around. For right and left, the number is inside the function and the sign is switched. If you remember coordinates, when you go right, it's always positive. When you go left, it's always negative. But for this case, when you go right, it's a negative. When you go left, it's a positive. So when you have x minus 2 here, all inside this square root means you move your graph to the right. So you move it to the right 2 spaces like this. So your graph will look something like that. And if you have x squared of x plus 2, this is square of x, you move it to the left. So now your graph will look something like this. So, so this kind of transformations, you have to be careful with it, because if you look carefully that this is outside, I call outside the root, and this is inside. So outside is up, down, inside is left, right. Okay, and the sign change for the inside. Next is a reflection. Reflections, we got two types on the X and the Y axis. When you have a reflection on X axis, you just kind of like flip it over on the X axis. When you have a Y axis, you flip it over on the Y axis. So this is the meaning of a reflections on the X and Y axis. For reflection on X axis, your negative has to be in front of the function. For example, like this one, negative square root of X. That means it's a reflection on the X axis. If you have Y axis, the negative has to be inside the square root. So when you have a square of negative X, this is where you do a reflections on the Y axis. And yes, you can have both reflection on the X and Y axis. Will look something like this, a negative, a root, and a negative. So if you have these two negative, again, it's not positive. Oh, two negative become positive. No, this means that you have to perform both reflection. You have to reflect this on the X, and then after that, reflect on the Y. So when you do two reflections, this is your function for this square root of this function here. Okay. So this is called reflections. And then lastly is what we call as a non-rigid transformation, is where you begin to do what we call as stretching and shrinking. So we got a vertical stretch. A vertical stretch is where you take something and you vertically stretch it. Okay. So if you have a parabola, and if you vertically stretch it, the parabola will become skinnier. Okay. Vertical shrink or vertical compress means you compress vertically. So if you have a parabola, if you compress vertically, it will become wider. Okay. Same thing with horizontal stretch and horizontal compress, because this is vertical, this is horizontal. So when you do a horizontal stretch, means you stretch it horizontal like this. So if you have a parabola, if you horizontally stretch it, this parabola is getting wider. For horizontal shrink or horizontal compress, you got a parabola and you try to shrink it this way. So this parabola will become skinnier. Okay, so that's the reason why they are kind of the same but different. How different they are depends on the number. So as you guys remember that when you add and subtract is where you move up and down. But what happens when you multiply or divide? That is where the stretch is, the stretch and the shrink. So if this number that you're doing is greater than 1, like 2, 3, 4, 5, then you have a vertical stretch. For example, 2 times root x. This 2 stands for a vertical stretch. When you vertical stretch, your y value changes. If I put a 2, means that your y value will double. Okay, so all your y value used to be 1, become 2. Used to be 2, become 4. So you double if you have 2 in front. If you have a 3 in front, then you have to triple all your y values. Okay, so that's a vertical stretch. A vertical shrink is where the number is between 0 and 1, kind of like a fraction. So for this case, you get 1/2. So this is considered a vertical shrink, where your y value in this case is gonna be half. Okay, it's gonna be half. So that's what we're gonna do for this. And you notice that this number is in front of the function. So that's why this is a vertical. For horizontal, this number is inside the function. If this number is between 0 and 1, it's called a horizontal stretch. So like example, 1/2 x inside the root. So again, x changes. And for this case, your x will be actually double. Yes. So a lot of students will ask me why double. The reason why is because when you horizontal stretch it, your x value will double. So that's why it becomes wider. Okay. So this will double. So when you have half, it'll be double. When you have a 1/3, it'll be triple. And this one, you'll cut your x value by half. Okay. This is when c is greater than, when c is greater than 1 and is inside the function. So this is all the horizontal, all the transformation we have. And usually we have multiple transformation. So which one goes first? Then you have to follow orders of operation. You guys know orders of operation, right? PEMDAS. So that means that you start from the parentheses and then exponents and then multiply, divide, and addition, subtraction. So don't start from addition, subtraction, don't do backwards, okay? So you will get all your graph wrong. So start with the parentheses and then orders of operation. Okay. So we're going to talk about something like question 1 here. This is the main part of, you will get this in your test. And first, function G is given to us. A, you have to identify the parent function. B, you have to describe a sequence, sketch it, and then write G in terms of F. So what is a parent function? A parent function is what you just learned on 2.4. It can be a cubic, it can be a parabola, it can be a square root, okay? It can be steps, okay? Some of you who have the ebook is actually in, where's my ebook? There you go. This is in page, where's the page here? Should be a page. At the end of 2.4, where is that page? Let me see. I got my textbook. So if you have a textbook, you got all these parent functions given to you on page 202. Page 202. This is page 202. Okay, some of you want. So this is all page 202. So so it's in here. So this is all your parent function. So how do we know this question, what parent functions we have, is you just look at your 2.5. Here you have square, so your parent function will be x squared. So you will have a parabola. Yes, you have drawn me this parabola because in the test, this question, if I ask you for all A, B, C, D, this is worth 10 points in your test. Okay, so these are all have points. So your parent function is x squared. This is the parent function. You have to draw it out. And then next, describe the sequence. So for this case, we got the negative in front. We got one quarter, we got 2, and we got -2. So we got like 4 transformation here. One is a negative, one is a quarter, one is a 2, and one is a negative. So which one we do first? We follow the orders of operation. So PEMDAS. PEMDAS means parentheses. So we do inside this parentheses first. And since this is a +2, a +2 means you move left 2. Don't forget, inside the sign change. If it's a plus, you move left. And then next we do multiply. We do the half and the negative. The negative means it's a reflection on the x because the negative is outside. 1/2 is a vertical shrink because this 1/2 is less between 0 and 1 and it's outside the function, so it's a vertical shrink. And then finally, the -2 at the back means you go down. So this is the sequence of transformation, means you have to move left 2 first, reflect on the x, shrink it, and then move down 2. So in this case, what we do is the left 2, you take this point and you move left 2. So this is your parabola in this case by moving left 2. And then once you move left 2, you have to reflect this on the x-axis. So you go up and down, upside down. Okay, so you go downwards now. So this is a reflections on the x-axis, and then you vertical shrink it. So when you vertical shrink it, this graph will get wider. Okay, and then after that, you move down 2. So this is the graph of the function for question 1. And then the last part, this is part C, and you have to sketch a graph. Part D is write G in terms of F. So f of x is x squared. So what you do is you take all this and change it to become f of x. So you have a -1/4 here. You have a -2, which is exactly the same. Because of the square here, the square will change to become f of x. And the reason why you have a +2 inside is because of this +2. So what usually it is when I want you to write G in terms of f, I just want to take this x squared to write in f of x. For example, like this is the greatest integer f of x. So if I want to write this as a G in terms of f of x, I just take 2f and then the x plus 5 inside. Okay, so this is usually how we do this. This is the most important piece of this. So I'm going to show you how to do it on your online homework so you guys know what to do because it's a little bit different from your online homework here. So I'm going to look at 2.5 so you guys can see what's going on. So some of you asked me, do you need to know this graph? Yes, the answer is yes. Do you need to know all this parent function? In this class, you will learn around 12 parent function, 12 or 16. This is 8 of them. So you still have another 8 more to go. Yes, some of you asked me, do you have more parent function? The answer is yes. This is 8 and you have 8 more to go. And then when you go trigonometry, you got another like 8 more. Okay. All right. Now, before I continue with my homework here for you guys, I want you guys to go ahead and take attendance. So type present. So please, everyone type present on the chat. Thank you. Yep. Everyone, please type present. So we will. Yep. And don't forget, your online homework tonight is 21, 22, 23, 24. So you have 4 homework sections in this case. Okay. You got 4 homework sections, so make sure that you do this. So we're going to talk about 2.5 now on your online homework. So example is like question 5a. They're asking you to, how do you write this in equation? So first thing first, they give you is the absolute value of x. Absolute value of x, if you look at the equation, is a V shape like this. So you notice that this V shape already go upside down. So that means that this one has a reflections on the x-axis. Okay, and then on top of it, usually the V shape start at 0, 0. So this one actually move 1, 2, 3 to the left. So this transformation says that we have to take this absolute value, move 3 left, and then reflect it on the x-axis. Can someone tell me how you write this function out? Yep, good. Yep, go ahead and try. Yep, I got you guys. Yep, go ahead. Anyone know how to write this answer out? If you have absolute of x, you have to reflect on the x-axis and left 3. You guys remember what happens when you have a reflection on the x-axis? We put, if you remember it, reflections on the x-axis means we have to do what? We have to put a negative in front of the absolute value. And then you have to move left 3. Left 3 means it has to go inside, become +3. So can someone tell me what is this function will looks like if you do this transformation? Y equals to what? This is something you will get in my test, so that's why you need to know this. So the reflection of x-axis will give you negative, and then absolute value. Left means you have to add 3, x plus 3. So this is the answer for this question. So it's negative absolute value of x plus 3. Okay, so make sure you guys know what to do here. This is something that a lot of students, you might need to, a little tough, it's not easy. Okay, this is a square root function. And if you look at a square root function, this is exactly the same shape. So that means we know this is a square root function. So there's no reflection here. But the original of this point is at 0, 0. So can someone tell me what transformation do we have that move from 0, 0 to this point? Anyone know? What do we do from here, move to here? What do we move here? Left, right, up, down. What we have? What's the coordinates of this one? You want to know the coordinates of this one? If you know the coordinates, then you know your transformation. Anyone? You move -2, 6. Yep, so that means -2 means you move left 2, right? And 6 means -6 means you go down 6. Okay. So -2 means you move left 2 and down 6. So how do you write this function? When you move -2, y equals to square root of -2, like negative left 2, left 3. So you have to add, right? So what you add here? X plus 2 And then when you go down 6, it's become what? -6. So this equation is going to be a square root of x minus, not x minus, x plus 2, and then you -6. So this is what you go down to, left 2, down 6. Okay. So let's do something else more difficult. This is the one that have A, B, C, D, the one that we just did. Let's do this one. Okay, the one that's 10 points. This is the one that costs the most points. So what is the parent function for this case? Anyone know what's the parent function for this case? Is that x, absolute of x, square of x, x squared, x cubed, 1 over x, the greatest in the step one. So what do you think about this one compared to this? Anyone know what this basic function is? Parent function? This is your x to the power of 3. So this is the basic parent function. So can someone tell me what kind of sequence of transformation we have here? Does anyone know what is this negative means? Negative? In front of negative, what does that mean? Anyone?
Horizontal.
The negative and the -2. Anyone know what is this 2 means? What transformation we have?
Horizontal shift to the 2 units right.
2 units, not to the right. That's wrong. Why 2 units to the right is wrong? Left is wrong. Left and right is wrong here. You don't move left and right here. Why you don't move left and right? Is because this -2 is outside the x cube. If you want to be left and right, then it looks something like this. X plus 3 to the power of 3. This 1. This is where you move to the left 1. And this is where you move to the right 1. So you guys need to watch carefully the number. Since the number here is outside, not inside the cube. So this is actually you move down. Vertical shift down 2. And the negative means you have to reflect it on the x-axis. Tough, huh? I didn't say this is easy. This is tough. So what you do here is you take this graph that you have and you will reflect this on the x-axis. So when you reflect this on the x-axis, you go this way, the other way. And then what else you need to do here is you have to move down 2. So which one of this graph looks like being reflected and moved down 2? A, B, C, D.
D.
D. This is the one that is reflected and moved down 2. And lastly, you have to write this G in terms of F. So what you do here is you have the negative here. So you put a negative. Wait first. What happens on this question is very tricky. Is they switch it around. So if instead of negative x cubed minus 2, he wants you to write this as -2 minus x cubed. You can do that because you just flip your terms around. So what happens here is, in this case, this will become a -2 minus negative f of x. And because the x here has nothing left or right, then you will just put f of x. But if this is an x plus 3 like what we have over here, then you have to use f of x plus 1. This is how you write it in the G function. Okay. So it's tough. I didn't say this is easy, all right? I didn't say this is easy. This is tough. This is tougher than, it's getting tough, yep. And you will use this in future, not just 2.5, chapter 3, chapter 4, chapter 5. Let's do one that is square root. There you go. So can someone tell me what is the parent function of this? This is easy, it's not.
Square root.
Square root, yep. So you do the square root of x. Very good. 1/4. Does anyone remember what is the... So ask yourself every time you see a number is first, I'm going to show to you what I do usually. I ask myself, is this number being add, subtract, or multiply?
Multiply.
Multiply. So that means this is going to be the non-rigid one. Is this number inside or outside the root?
It's outside.
It's outside, so it's going to be vertical. If it's inside, it'll be horizontal. Now, is this number is greater than 1 or between 0 and 1?
Between 0 and 1.
So it's a vertical shrink. So you will look for vertical shrink. And that's only we have. Okay. So what happens when you vertical shrink is you got the function looks something like this. And you have to vertical shrink it. Shrink it means you push it down like that. Stretch is pull, shrink you push. So what happens to this function? Does that go up or does that go down when you shrink it?
It's going down.
It's going down. So what do you think the graph? A, B, C, D. A, B, C. So it'll be A because it's shrinking. Okay. But if this is a 4 root of x, then your answer will be this one, because that will be pushing up. So how do you write this in the G of terms is because we got the 1/4 over there, so you just put 1/4. Okay. And this is how you do your homework. Again, you have to practice this. This is very important. And I want to point out to you that you guys know to watch it, right? Have you guys been doing this when you do your homework?
Yes.
Yes, because it really helps you. Mostly everything I assign here has the watch it button here. So I would recommend you to watch it. If you say, I doesn't know how to do this, or you get it wrong, watch it. Because it will take, watch it. I would recommend you to watch it. Okay, so today we end in 2.5 here. So tomorrow we'll do 2.6. Tomorrow, Thursday, we'll have to do 2.6 and 2.7. So so this is the end of the class here. We will end in 2.5 here. And again, this transformation is very important, and you have to know this. We will use this transformation in chapter 3, 4, 5, and then when you go to trigonometry, we will use that also. Okay. The rest is pretty much not that difficult. Once you get hang on to this transformation, you'll be fine. Okay. I will post some Khan Academy on this. They have all this in Khan Academy. So I'll post it in D2L so you guys can watch it if you want to have more information how we do all this transformation because it's very, very important. We're gonna end. So everyone did type in present, right? So don't forget, those who forget to type in present. Yep, don't forget to type in present here. That's it for today's class. So I'm gonna unrecord this.